All right, you pre-calculus fans, we're going to review some problems that are very similar to the problems not only on your semester exam review, in fact some of them are identical, but are also somewhat similar to some of the problems that are on your semester exam. So we'll start with some equations. Notice here I'm solving on the restricted replacement set from 0 to 2 pi. So typically when they have it written this way, you're assuming that you're writing your angles in terms of radians. If they said 0 to 360, most likely in degrees. And don't forget, sometimes the equations are not as direct. Like here I'm going to have to divide both sides by 4. And then I'm going to have to take the square root. And I don't know how many people I've noticed here forget to take into effect the plus or minus. And so this is going to be plus or minus the square root of 1/4, which is 1/2. Well, here's where you need to know your unit circle. If you don't have a unit circle memorized, it's going to be a tough one to do. So theta is equal to what? Well, when the cosine is positive, what happens? Remember, cosine's positive first and fourth, negative second and third. In the first quadrant, left-hand rule, at 60 degrees, the cosine is 1/2, the sine is the square root 3 over 2, so I want the 1/2. So it's at 60 degrees, or pi over 3. And then I use that as a reference angle for the second, the third, and the fourth quadrant. So, second quadrant, pi minus pi over 3. Third quadrant, pi plus pi over 3. And then the fourth quadrant, 2 pi minus pi over 3, which is 5 pi over 3. And those are your 4 answers. Now in this problem, this one is nicely set up. It looks like a quadratic. It wants you to solve it like a quadratic. Solve it like a quadratic. See if it'll factor. And I think this one does. This is 5 cosine x. Let's see, 3 cosine x. I think I need the minus 2 here to get the minus 10. And here to get the, I need a plus, what do I need? I need a plus 1. So that's going to give me here that 5 cosine x plus 1 equals 0, or 3 cosine x minus 2 is equal to 0. Well, to work this problem out, you're going to need a calculator. So which tells me that if you have a problem like this on your test, and you're not allowed to use the calculator for this particular part of the test, that tells me that they're going to come out to be nice values, probably more like halves than, in this case, negative 1/5. And also 2/3. So I grab my calculator. I'm going to put my calculator in radian mode. And it is already in radian mode. Good. And then I am going to take the inverse cosine. Now remember, cosine is negative in the second and third quadrants. The inverse cosine, or the arc cosine, its range is between 0 and pi, so it's going to be a second quadrant angle here. So let's see, I need to take the inverse cosine of negative 0.2, and I get, as one of my answers, I'm just going to round it to 2 decimal places here, 1.77. Now that's in the second quadrant. To find the reference angle, remember in the second quadrant the reference angle is pi minus the reference angle to equal the second quadrant angle. So if I do pi, if I can find my pi button here, if I can do pi, and I subtract from that 1.77, that's not my reference angle, that's my reference angle, which turns out to be 1.37. The reason I need to know that is I need to know my third quadrant angle, which is pi plus this 1.37. So one more time, pi plus 1.37, and I have 4.51. So those are the 2 angles that solve this part. Now I've got to do something very similar to this to get the other 2. Now notice here this one's positive, so my first value here, if I take the inverse cosine of 2/3, I get 0.84. Again, I'm just rounding to 2 decimal places. And that's not only an answer, that's my reference angle because it's the first quadrant. So to find the fourth quadrant, it is 2 pi minus 0.84. So you can see this on my calculator there. Maybe it looks like there's a glare somehow. Sorry about that. There we go. And I'm going to end up with 5.4431 and so on and so on. So those would be my answers. You have to know your reference angle to look these guys up because there are going to be two answers. An inverse cosine is only going to give you one of them. Alright, here's another one that involves cosine. First, isolate the function. So I add 1 to both sides. I get 2 cosine 2x is equal to 1. Divide by 2. I get the cosine of 2x is equal to half. And remember, when you divide both sides by 2, you're not canceling that 2, you're canceling this 2. Now, I'm going to solve for 2x, and then, as if it was just a single angle alpha, right? I'm going to solve for 2x, and then we're going to divide by 2. Now, because it's 2x, graphically, you're squeezing the function in, which means there's going to be more answers. Double the answers. If this was a 3, triple the answers. So I'm going to, well, isn't this nice? Remember this guy up here? Cosine, 1/2. That happens in the first and third, so you have, or first and fourth, so you have pi over 3, you have 5 pi over 3. And if you stop here, you're going to miss out on 2 answers. And you say, no, it's not, that's it. No, because I've still got to divide by 2, so I'm going to add 2 pi to that. That would be 7 pi over 3. And I'm going to add 2 pi to that, and that's going to be 11 pi over 3. So if I divide through by 2, I get pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And again, I have double the answers here because of that constant right there. It's going to tell me, be on the lookout for more answers than just fits the immediate look here. When I was doing this part of the problem right here and solving for the angle, I have to still divide by 2. Double the answers. If it was a 3, triple the answers, and so on. So these are similar to equations that are not only on the review, but also on the exam itself. Now I have some exact values. So if they're asking for exact values, the calculator most likely isn't going to be much help. So you need to know a few things, and the first thing I need to know is that the cosine of 7 pi over 4, I need to know what that's equal to, because you say, no, they're inverses. You're just going to get 7 pi over 4. Remember, for inverse cosine, your range is between 0 and pi, or 0 and 180. And 7 pi over 4, that's in the fourth quadrant. That's too big. So I find the cosine of 7 pi over 4, which turns out to be square root of 2 over 2. And then I say what angle between 0 and 180, or 0 and pi, is it, call it alpha, such that the cosine of this alpha is equal to the square root of 2 over 2. Well, it's become another equation here. So what angle is that? Well, it's got to be the first quadrant if it's positive, and that's going to be pi over 4. So this is going to equal pi over 4. Very similar problem here. The inverse tan of 1 has to be determined first. Then you're going to take the cosine of that. So what angle is it such that the tangent of this angle is equal to 1? Well, remember, inverse tangent, the range is between negative pi over 2 and pi over 2 non-inclusive. So what you're going to have to do here is you're going to have to figure out what angle from negative pi over 2 to pi over 2 has a tangent that's equal to 1. Well, it's positive, so it's in the first quadrant. And the tangent is sine over cosine, so it's got to be the sine and cosine having the same values. Well, that happens at pi over 4 because you get the square root of 2 over 2 all over the square root of 2 over 2. So this is going to be pi over 4, and the cosine of pi over 4 is the square root of 2 over 2. Not so bad if you know a little bit about the range of the inverse trig functions and you know your unit circle. You've got to know your unit circle. Alright, so here again, inverse tangent. It's got to equal an angle, such that the tangent of this angle is the square root of 3. Now remember, tangent sine over cosine. And since this is square root of 3, you got to figure, oh, it's got to be a special angle. Well, as it turns out, we want the sine of this angle over the cosine of this angle to equal the square root of 3. Well, that would be great if it's like square root of 3 over 2 all over a half, because that's the square root of 3 over 2. And you say, oh, what angle is that? Well, we talked about them not that long ago. When the cosine's a half, turns out that this is pi over 3. So alpha is pi over 3, that's my answer. These aren't gimmies, you got to think about them for a little bit. Now this one, heaven help us here, because this one, negative 3/5, that's not some value on the unit circle. So again, I'm going to call this angle here, because that's what this is. This is an angle, and since it's negative, this angle is going to be in the fourth quadrant, because remember, for inverse sine, a little bit like inverse tangents, between negative pi over 2 and pi over 2 inclusive. Right? So I need to find the angle such that the sine of this angle is equal to negative 3/5. Here's what I'm going to do. I cannot construct a right triangle with a fourth quadrant angle, but I can construct a right triangle with the reference angle of a fourth quadrant angle. I'm going to call it alpha prime. Now if the sine of alpha is negative 3/5, the sine of the reference angle of alpha would be positive 3/5. Positive 3/5, opposite over hypotenuse. This is a nice little 3, 4, 5 right triangle. Alright, now what are they asking me to find? The angle? No, they're asking you to find the tangent of this angle. Well, the tangent of the reference angle would be 3/4. The tangent of alpha prime would be 3/4. But we know that this is a fourth quadrant angle. And the tangent of a fourth quadrant angle is negative, so this is going to be negative 3/4. Oh yes, I can guarantee you're going to see stuff like that. Alright, now this one here is a little bit more direct, because if you know the unit circle and you know the tangent is the sine of the angle over the cosine of the angle, so this is equal to sine of 7 pi over 4, that's going to be negative square root 2 over 2. The cosine of 7 pi over 4 is going to be positive square root 2 over 2. Well, this is just negative 1. This guy, he's too small. I need a positive angle and use my unit circle information. So I'm going to take coterminal angle, not a reference angle, a coterminal angle here. I'm going to add 2 pi. Well, here's some scratch work somewhere. Negative 10 pi over 3 plus 2 pi, which is like 2 pi over 1. I'd have to multiply top and bottom by 3. This is the same, not the same angle, but the same sine value is the same as, that would be 6 pi over 3, so this would be negative 4 pi over 3. It's still too small. So I add 2 pi again, which is 6 pi over 3. And I get 2 pi over 3. Now the sine of 2 pi over 3, that's not so bad. Sine's positive in the second quadrant. Don't forget, all students take calculus. So the sine of 2 pi over 3 is going to be square root of 3 over 2. Okay, here's another angle that's going to be a little bit of a problem, not because it's negative, but because it's bigger than 2 pi. So instead of adding 2 pi, I'm going to find a coterminal angle that's smaller by subtracting 2 pi. Now notice the denominator is 3, so when you have 2 pi over 1, that's like 6 pi over 3, and I get 4 pi over 3. Now that's the guy I can deal with. He's in my unit circle. Same as 240 degrees. I know it's negative, but negative how much? Because in the third quadrant, cosine's negative, so that'd be negative 1/2. And now this guy here is a little bit like problem number 9, only I didn't even give you a number this time. We're going to write this expression in terms of y, in terms of like an algebraic expression. So I'm going to kind of set it up the same way with a right triangle. If this is an angle such that the sine of this angle is y, that means if this is the angle, the sine is the opposite over the hypotenuse, that'd be like y here and 1 here. So using the Pythagorean theorem, this would be 1 minus y squared. And the square root of 1 minus y squared, excuse me. So I'm trying to find the cosine of this angle, that'd be this guy over this guy, the adjacent over the hypotenuse. So I get the square root of 1 minus y squared all over 1, which is the square root of 1 minus y squared. Okay, drink that stuff in. I went fast, but you can rewind it if I went too fast. And the next problem is a story problem. In fact, I tried to find something that was like a problem in the book that was similar to this. So it says an airplane began its descent with an average speed of 250 miles per hour at an angle of depression of 3 degrees. How much altitude will the plane lose in 6 minutes? So here's the plane. It's starting to come down this way. Oh, this way. Now, here's the horizontal. So this is the angle of depression. This is 3 degrees. Alright, it comes down for 6 minutes at 250 miles an hour. Now 6 minutes is 1/10 of an hour times 250 miles per hour. That's going to be 25 miles. So it's coming down for 25 miles. Let's say that this is 25 right here. So again, I'm going to draw a horizontal and a vertical. If this guy is 3 degrees, if this guy is 3 degrees, do you see you have alternate interior angles between two parallel lines that are formed by this transversal? I want to figure out how much altitude the plane loses, so I want this. That's how much it drops down. Well, that's right triangle trig, that's SOHCAHTOA. I got the angle, I want the opposite, I have the hypotenuse, it sounds like sine. The sine of 3 degrees should be equal to x over 25. So x is equal to 25 times the sine of 3 degrees. Well, what's the sine of 3 degrees? I got my calculator handy. So let's see. Oh, I'm in radians. Hang on a second. Let me change my mode. So let's see. The sine of 3 degrees times 25. I get x is 1.308, and it goes on. I'm just going to round it, in this case, to 3 places. It'll tell you what to round to. If it doesn't, just round it to 3 places. And this would be in miles. So the plane descends 1.308 miles. That's probably pretty good. Now I ran out of space, so I'll do a few more problems for you guys, but I got to clear the board, so I'm just going to create a second video. Hopefully I won't need a third one, but I'll create a second video. So look through these problems. If you're unsure of stuff, ask questions on one of our Wednesday meetings that we have before the exam hits. All right, good luck with your review.